Hello guys, Summer's of English and Fisherman. Today I'm going to be showing how to do the Ptolemy theorem. I don't know how Ptolemy or just Ptolemy, I don't know. So basically this is a theorem that involves using cyclic quadrilaterals, and those are like quadrilaterals which basically can be I'm not sure exact, but it can be used like it's kind of like something that I think can be inscribed in a circle. So let's find the actual meaning. Wait, so it's like, yeah, it can be inscribed column with all its vertices lie on a single chart. So it's kind of like a triangle with circle. That triangle is basically can be inscribed in it. So let's start. So let's pretend we have a circle here. Oh yeah, I remember. I have an easier way of doing it now with that thing. Then let's just make it. So this is gonna be a rectangle. And we need to talk about the diagonals here. So we have one diagonal going there, basically. One diagonal going there. And let's name these points quickly. So you have A, B, C, and D. Perfect. Okay. So our diagonals will be DB and CA. So Ptolemy theorem, it's not something I really know how to prove, but it's something that can be useful. I'm going to be making some like sample problems, but let's look over how to prove. Let's see the proof together. So I don't even know the proof. So yes, it's called inversion. I knew that. So let's choose with respect to a circle of A to B, B to C. So yeah, this kind of is very showing theorem. It's not helpful. Let's prove this theorem. Okay, perfect. So let's A, B, C be a random theorem. So, okay, so basically it has to do a lot with similar triangles, so I would advise you to search that. But I'm going to be showing what basically the theorem is, and sorry if I don't know how to prove it, I kind of just use the concept, and how some sample problems you can be using. This is basically saying, let's have these. You have opposite sides here, so let's call it AB and CD. Let's just multiply those for a second. We also have AD and BC. Let's also multiply those, and we're going to add those together. So we're going to take a simple one. So let's make this 6, 6. So this is how you can kind of prove it. 6, 6, 8, 8. So this is so what will this be equal to? So 6a I'm using because it does have a diagonal, so you can find it is. So let's do AB times CA. So that's going to be 66. That is going to be 36. But let me tell you this. We're using a rectangle. It does not need to be a rectangle. It can be anything big. It doesn't need to be a rectangle at all. So that's the really fun part about it. And then 64. Now, of course, now you're going to say, of course, it's Pythagorean. So maybe not the best example. But let's think about it. Oh, I just erased the circle. Oh my god. Okay. So let me just. So there's one I know. So there are few hypotenuses that can be two triangles. So that's actually 65, I remember. You can have a 16 and 63. And let's pretend this is not a rectangle. And it can be 39 and 52. So let's see this. So this should be a quadrilateral, I'm pretty sure. If it's not a quadrilateral, I may have done it wrong. But let's do this quick with calculator. So we can have 39 times 16. Okay, so I need Google. This is not fair. 39 times 16 plus, we're going to have 63 times 52. And in this case, they'll be equal. So let's see what that is. 100. Give me a second. This is a total fail. I can't think right. Okay, sorry. So that's not the best way to explain it, actually. But basically, I'm just going to say the theorem. So I thought I can explain it, but it is tough. Oh, wait. What did I do wrong? I used the same diagonal. What? You can just, let's do it 3, 4, 5. And then, I don't know if I wanted to. Let's do 6, 8, and then we'll pretend that's 10. Okay. Well, 6 times 3, 18, plus 32, 50. Did you see that? 3 times 6 is 18, 8 times 4 is 32, plus 50. That is 10. This diagonal is, sorry, this diagonal is 5. This one is 10. Sorry, so yeah. This is 4, so I mixed it up. This is 5. This is 10. That's 10 times 5, 50. So that's basically saying that these two, when you multiply, is equal to AC times BD, the diagonals. Now let's see some problems where this can be true. So I'm going to erase this and... Okay, so why did I erase it all? But I'm just going to undo it again. So let's have our circle. Let's have pretend it's not going to be a rectangle. So pretend we need to find out. We have to see. Let's say we have two sides of 20. Let's say 20. We have 20. We have a side of 21. We have a side of 15, and we have a side of 16. Yeah, okay. Yeah, that makes sense. Okay. So, to do this, basically, let's pretend these are two diagonals. Now, the thing is, because it looks like a rectangle, this diagonal will look like it's pertaining to this one as well. But this diagonal, we're going to pertain it to this. So this diagonal will be based on this. And we're going to make, it's going to be a right angle, so we can actually realize that this is hypotenuse. And then this will just be, whatever, 21 times 15. It could also be 20 times 16. We have 20 times 21, sorry, 20 times 15 is equal to 16 plus 16 times 21. We're trying to find this diagonal right here. Well, we have 20 times 15. We have 300 plus 21 times 16, whatever that is. 336. That equals 636. Now, how is this going to help? Well, I told you this diagonal, it's kind of confusing because it's not always with a rectangle, but we pretend this is a right angle. 20 and 21. Now, usually, if you have already another diagonal, it's over. It's just like algebra. But this, we don't have it. We have two unknowns. But it can be unknown. If we know this is a right angle, this is 20, 21. It's a right triangle. 20, 21, and this will be 29. So it's basically 636 divided by 29 is the other one. And 21.93-ish. So that's basically the other one. Now, it's very confusing to do a problem like this because it's better if like some like actual like math community makes a problem. So if you find these problems, but it's hard for like somebody like just a regular person like me to make it because it's hard because you kind of have to make like a trapezoid and all that stuff. But just remember, if you have two opposite sides, multiply these, you multiply the other sides. So this times this plus this times this is equal to the diagonals multiplied. Thank you for watching. Yeet.